The name of the game is to turn up this surface here that runs on the oil seal, because it is worn and it's just going to leak oil if I put that back in. So I'm just going to skim this down and fit a steel bush over the top, or a spacer or a shim, or what you want to call it. And the question is, how close are we? Still a way to go, I think. Close. It's close. We're going to super glue that on there when we're ready. Like a nice sliding fit. Yeah, rock and roll. So the leading part I did is going in with a little bit of play in it, but if we look up this hole, look, it's not the nicest of holes. It's all scored and messed up inside. The question is, would that hammer on as it stands? I'm not entirely sure it would. No, I think we're going to take another tiniest cut off and probably anchor it on there with a bit of super glue. So I'm taking off a thou. Starting to cut about now. See the score marks there where I've tried to put the pulley on. If I wipe that out with a cloth, it might help. Right, so we want to get to this side of it, so this is the actual business side. And the question is, will that go on? If I heat this pulley up, will it expand enough to drop over there? Should we try it? Should we give her a go? Let's turn the motor off. Now, as you know, I can push this out with the press if I need to get it out, but as you know, for every 100 degrees increase in temperature, steel will grow by about 1 thou. So if we get this up to about 150, it might just slide on and contract into position. Trying to get a bit of a colour change there. Blow torch down. See if she drops over or not. Yeah, look at that. So when that cools down, that will be locked on there, and I'll have to press it off. But I don't mind about that too much. I don't mind too much about that. That's already locked. Woo. Interference fit. Actually, I can see, if I turn that on now, you can see that puller's not running. I can see that's out of square, look. Watch this. That's how the crankshaft. That's how the belt's been running. Obviously, it's been clobbered at some point, this pulley, so we're going to have to heat it up and straighten it as well. You could say buy a new pulley, but yeah, where's the fun in that really? Anybody can buy new stuff. This is the authentic 1940s pulley on here, hopefully. I might be unsuccessful, let's face it, but who knows? But it's well out of true. That's still pretty hot, but that's on there now. I can machine that if I want to. This surface here, I can't really clean it up, because if I clean it up, it'd be under diameter for the oil seal. It might work, but what I have somewhere. Now this stuff is 1 3/4, which is the same diameter of that bush there on the pulley, but it's 2mm wool thickness, which is a bit thick, and I was going to machine this down, probably machine something up the inside of this and make a sliding sleeve to go over it to give it a good bearing surface for the oil seal, and then polish this. But it's seamless steel tube that I use to make a roll cage, and that's the bit I've got left, or handy bit I got left. I can cut it, machine the inside, machine this, and do a similar thing, push it, press it over, and then tidy it up afterwards. So that's the plan. And if it doesn't work, the worst thing that comes from it is the fact that the pulley is then going to be scrap. I can't take this out of the vise at the moment because I've machined it absolutely true, and the boss looks to be running pretty even. I could machine this down and just see what diameter I'm left with, and then check that on the spec of the seal. I might just do that actually. That will save doing the sleeving if it's a good fit still in the oil seal. Let's see how much we have to take off this just to clean up the surface, shall we? What do you think? I know there's quite a lot of play, because you can buy, what you can buy is metal sleeves that go on. They're called shaft repair shims, and they're like just a top hat, very thin hard steel section which you can press over. They're about 12 to 15 pounds each, and they say if you've got a 1.75mm shaft, 1.75 inch shaft, you can press this thing over and it will still work in the same oil seal. It will just expand the oil seal a bit further. So presumably if it's slightly undersized but running true, you might still get a good seal. We could try it, couldn't we? It's going to take a lot of time. Let's just machine this down so it's smooth and just measure it and see what diameter we're left with. That's a good idea. Ooh, what to do? If I took it down the full 2mm wall thickness, that would take 4mm off the overall diameter. I think that's just too much. Right, chattering a bit. Might need a bit more of a pointy tool, I think. You see that? Yeah, look at that. Jesus. But Jesus, yeah, there's still a significant divot in there, you know. I think that's, if I can get the pulley running, I could machine some off the pulley so it runs further into the seal. Let's just measure that diameter and see what we're working with there. We might just get away with it, or we might not. We shall see what diameters we're working with here. This doesn't get used very often. Come on, baby, show us what you got. And that's it. That's it, just there. We have got 1.75. 1.7255. We got 1.73, so it's 20 thou undersized now. So we've taken probably 10th off each side, and if I just get the oil seal, if I can find it. In fact, that's the oil seal. Right, so here's the oil seal. Not going to move that. Ooh, Christ, that's quite tight, you know. I think that'll be alright on there. That is tight. But you can see, ooh, I'll just show you where it's running. The actual active part of the seal is this back ring here, so the seal would have to go on quite a long way. So there. So the front of the cover would have to be a millimetre or two in front of the there's got some clearance. You got the actual cover. Let's have a look on the cover and just see what the detail on the cover is, shall we? Ooh, it's quite tight. I'd run with that. I'd run with that. If it was bearing on the right part of the 2 or 3 mil clearance. So I think our seal probably 5 mils at minimum, absolute minimum 5 millimeters from the back edge in there, from the seal to the back edge of the pulley, or the front edge of the pulley, would be about there where it would be running. And you can see running there, it's right in the middle of that, where that wear mark is, just there, this wear mark here. So what do? Take it down further? I think I'm close. I mean, it's going to be much better than it was, but I think it still might leak, especially if it's undersized. Yeah, I'm going to have to take another thou off. Let's try another thou. Another 1/1000th of an inch. In for a penny, in for a pound. If you put it together as it is, it'll just wear the seal out in no time, literally hours I should think, before it starts leaking. They just chop away at the seal, and then you've gone too far. We're left with that little bit of unevenness there. I wonder if the seal would accommodate that or not without going any smaller. What do you think? Answers on a postcard. Yeah, that's going to run alright, I reckon. Don't want to go any smaller. It's going to be running right there, actually, if you're looking at the way the thing builds up. All the dimensions stack up, it's going to be running right on that bad patch, but I might be able to adjust it just to run on the good patch inside the bad patch, if you see what I mean, with that part in the middle, intermediate part of the seal might work. All depends where it goes on. Yeah, it's, a lot of the tension has been lost. It's still pretty tight. I'm going to polish it, put it together, run it, and then be prepared later on, if I have to take remedial action.